Okay, it's like 100 degrees out here, but we're going to try to find out if this sequence here converges or diverges. So when we try to find out if a sequence converges or diverges, we take the limit as n approaches infinity of this sequence. So limit as n approaches infinity of the sequence, we have a negative exponent there. That means we have it in the denominator. We have cosine n pi over 2 to the n. That's what we're taking the limit of. So if we were to plug in infinity right now, we would get infinity in the denominator, and we would get cosine of infinity. Cosine of infinity, that's just going to keep going and keep going. Whatever values that are possible for it, it's just going to keep fluctuating. So we can't stop right there. We have to keep going. So what could we do? Well, we have to remember the squeeze theorem in this case. We think about the squeeze theorem because what else could we do, right? We can't just take the derivative and the derivative. So the squeeze theorem is telling us that we have three functions, right? We have a function, and it's related to the second function in this manner, i.e. the second function is greater than or equal to the first function, and then the third function is related to the previous ones in this manner. So if f of 1 of x, with the limit as x approaches infinity equals the limit as x approaches infinity of this third function, or as x approaches really any number. But if they're equal, and this one sandwiched in between them, that limit of the second one is also going to be equal. The limit as that approaches infinity, that second function, or any other number that it's approaching, it's going to be equal if they're all approaching that same number or concept in the case of infinity. So that's what the sandwich or squeeze theorem is telling us. So let's apply it here. This is going to be the squeezed function. So we're going to let the limit as n approaches infinity of cosine of n pi over 2 to the n. With this now, we've got the same situation, right? We plug in infinity here, and that would just keep going, that would just keep fluctuating, and this would go to infinity. But the question is, what would it be fluctuating in between? Let's think about this. I mean, we have a sequence. A sequence means that for each n, we're plugging in 1, we're plugging in 2, we're plugging in 3, we're plugging in 4, 5, 6, 7, so on. That's what a sequence is. So if we were to plug in 1 for n, what would that be? That would be cosine of pi. What is cosine of pi? Cosine of pi is -1, right? This is -1. If we plug in 2 for n, we get the second term of the sequence, which is cosine of 2 pi. And that would give us 1. And then we would plug in cosine of 3 pi. And that would give us -1. And so on and so forth. We plug in cosine of 4 pi, and that would give us 1. It's just fluctuating between -1, 1, -1, 1. That's all that's ever going to happen. So that's the only possible value that this limit could be. So we got it squeezed. That numerator is squeezed between 1 and -1. But we still got the denominator. We can't just leave that. We got 2 to the n, 2 to the n, and this is a limit going to infinity, and this is a limit going to infinity. So if this 2 to the n goes to infinity, if n, which is an exponent in the denominator, and that exponent in the denominator goes to infinity, this goes to infinity, you got a number, -1 over infinity, that's 0. Okay? 0. Same thing happens here, as we can see. So we got 0. By the squeeze theorem then, by squeeze theorem, the sequence converges to 0.